All right, well, on Saturday, April 2nd, the 6th annual Seacoast Sea Perch Regional Competition was held at the University of New Hampshire down in Durham. Now, this event teaches students to build remotely operated vehicles, or ROVs, from low-cost, easily accessible materials and following basic engineering and science concepts. This year, 147 students, including Claremont's Rogue Robotics of 4-H, competed against each other. There were two staggered events, an obstacle course of submerged hoops and an orbs course, which tested the ROV's ability to collect and control items with precision. The Claremont team placed second as runners-up in the Sea Perch competition and are going to the national competition in Baton Rouge, Louisiana this coming May.
We are at our Rogue Robots of 4-H building. We rent a couple of rooms here, and we have middle school, some elementary school, and high school students doing various robotic activities. We recently went down to a regional robotics sea perch competition down in UNH, and our team came in second overall and won a spot at the national competition down in Baton Rouge, Louisiana.
With underwater robots, we have to waterproof the motors with toilet bowl wax. They're tethered, they're not remote control, so we have to worry about the tethers getting tangled on things. And it just presents a unique challenge as opposed to a robot that was meant to function out of the water. All right, so we have a tether plugged into our remote control module, and then this control module is hooked up to our battery. And when I press separate switches, and when I press them, the corresponding motor will move. So right motor, forwards, backwards, left motor, forwards and backwards, up, down, and then you can do combinations of forward, backwards, turning, going down and turning. Steven and Allison are our best drivers. Andrew and I can drive, but we prefer the spotting role, where we have one person driving and the other is able to keep a better eye on the robot and move around. And so when we release the ball to float up into a milk crate, the driver is staying over and looking where it is, but because of water's refraction, it's hard to see, so the other person is able to look right over the crate and the ball can be aimed more easily. The underwater obstacle course is a long piece of PVC pipe with hoops set up in different orientations, and we have to go through the hoops. So some of them are just straight that we drive right through and then we're able to come back. Some of them are angled, so we have to come up and in. Others are perfectly straight up and down, so we have to either float up or come down through. And then once we get all the way through, our tether is also all the way through. So getting back, we have to come back the exact same way we went, or we end up tying ourselves in a knot.
These students have been with us for many years. They have been involved in the Sea Perch since they've been in middle school. I've watched all of them grow up and be wiggly little middle schoolers and growing up into young men and women who are able to work as a team, listen to one another, value one another, and learn problem solving together. Very, very important skills, not just the skill of the engineering, but the skill of the communicating and valuing one another. And I'm really proud of them.
Now, beyond encouraging interest in STEM, that being science, technology, engineering, and math, the Sea Perch Challenge also teaches local youth to see an ROV that malfunctions minutes before a competition not as a crippling setback, but as an opportunity to get to work. Sea Perch Challenge has been an effective way to get students excited about STEM and the problem-solving challenges inherent to the four subjects.